we're going to be learning. Okay, so I'm going to give everybody 1 minute to go grab a coin. I want everybody to run and go grab a coin because we're going to be doing coin flipping today. All right, I'm counting down. Everybody 1 minute. Ready, set, go. Go fetch a coin. Wait, where's my coin? Hold on. Oh no, okay, there we go. Cool stuff, all right. I did, I forgot my coin. Princess, don't judge me. Don't judge me. But there it is, okay, cool, I got my coin. Are we all ready? Awesome, awesome, awesome. All right, let's get into today's lesson. No worries, Taven, welcome. Okay, let's go. Now it says, using a coin of your own, flip the coin 10 times and write down what it lands on each time. All right, so take it away, peeps. You need to flip your coin 10 times. Okay, let's go. Princess like, I forgot which is heads and tails. Just pick one. Pick one. Pick a side. My lady can't even flip. Shaden doesn't know how to flip. Ask a family member. Ask a family member to help. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8. And then last time. Okay. Okay, cool. All right. That's my answers. Give me a thumbs up in the chat if you flipped your coin and you've got all your answers. Right. Those are my answers over there. All right. Mamelo, I see your hand is up, my sweetie. What's up?
Hey, ma'am.
Hi, my sweetie. What's up?
I've got 7 heads and 3 tails.
Beautiful. Okay, 7 heads, 3 tails. I'm going to write that here. 7 heads, 3 tails. Okay, we're going to use your information. I feel like I like yours a little bit better. Okay, all right. Because mine is also kind of iffy. I feel like our coins are rigged. Why do I feel like I also got, no, I got 6 heads and 4 tails, but it seems, okay. Now, let's do this very quickly, okay? If we had to, remember guys, if I had to do the probability, and I forgot that I changed this to really thin. If I had to do the probability of getting heads, remind me again in the chat, if I flipped my coin once, and I wanted to figure out before I flip my coin, what my probability of throwing my coin once would be. What would I get? Correct, Abigail. That's it, guys. Excellent. Good, Jessica. That's it, Sipo. Good. We would get a probability of 1/2. Right. Now, let's say we actually flip our coin, and the answer we get is actually tails. Instead of getting heads, if we flip our coin once, we get tails, right? Now, if we get tails, that means this probability of heads then goes down to 0 because we didn't actually get heads. We got tails instead, right? Or not the probability, the actual answer to our experiment is tails and not heads. Okay, now if we do this 10 times, if we flip the coin 10 times, what is the probability that we will get heads? If I flip my coin 10 times, what will be the probability that I get heads times 10? It would be 5/10. Correct. 5/10, which still translates to a half. Yes, 5/10 is still the same as a half. Correct? 5/10, half, same thing. So even if I flip my coin 10 times, my probability of getting heads must still be a half. But if we look at our actual answers, Mamela over here, Mamela's answer for the probability or for heads would be 7 over 10, because 10 out of 10 times that she flipped her coin, she would have gotten 7, she got 7 heads. That's different from our actual theoretical probability. Okay, so relative frequency is what actually happens. And like we learned on Monday, theoretical probability is what we predict. Okay, give me a thumbs up if this makes sense. Okay, our prediction was that we would have gotten 5 out of 10. That was the prediction for heads. But if we look at the actual answer that we got, our probability, or not our probability, our actual answer, our our relative frequency is now 7 over 10. Correct, Keegan, beautifully put. So theoretical probability is what we guess. It's our calculated guess. Relative frequency is the answer we actually get. Okay. I want everybody who gets me to give me a thumbs up in the chat. I'm going to ask one more time. Give me a thumbs up in the chat, peeps. Beautiful. Faith, what's up?
Ma'am, I wanted to ask how you got 7 out of 10.
Okay. Remember, we flipped our own coin, right? How many times did you get heads flipped your coin?
Ma'am, I got 3 times, ma'am.
Good. So that means my frequency is 7 over 10, but your frequency will be 3 out of 10.
Okay.
Do you get what I'm saying? So
yes,
do you see how your prediction and your actual answer, not the same WhatsApp group?
Yes, ma'am.
Good. All
okay,
right.
Thank you, ma'am.
Correct. Okay, cool. I'm about to do exactly that, Jared. Okay, I'm going to do exactly that. Yes, of course, we can do another example, right? Now, the coin flipping example works best because we can all flip a coin, right? But if we think about this, guys, if I had to roll a dice, let's say we are rolling a dice, right? If I roll a dice, what is the probability that I will land on a 2? What is the probability that I will get a 2 if I roll a dice? Okay, good. There's 2 only comes up on one side of my dice, or die, English, right? One side of my die. So my probability is 1 over 6, right? Now, what happens if I roll my dice 5 times and I get a 3, then a 2, then a 2, then a 4, then a 6, 1, 2, 3, 4, 5, and then I'm going to roll one more time, a 1. Then I roll a 1, right? If I take this probability, because I rolled my dice 6 times, I'm going to take this probability and I'm going to multiply it by 6, right? If I do it 6 times, right, I'm going to get 6 over 36. Okay, I'm going to get 6 over 36 because 6 times, if I roll my dice 6 times, that's going to be the same as 36 times that I would have gotten the option. This still translates to 1 over 6. But if we look at the number of rolls that we actually had, how many times did I actually get the number 2 when I rolled my dice? I got it twice, right? Which means my actual probability or my frequency was actually 2 over 6 and not 1 over 6. Am I making sense? Beautiful. Excellent. I'm glad everybody's with me. So now, this is the actual answer, or this is the actual formula we're going to use for our relative frequency. Remember, relative frequency is different from probability because theoretical probability is telling us our guess. This is what we guess. When we calculate for relative frequency, we are going to take the number of times we get the probable answer over the total times that we've done the experiment. Okay, so relative frequency is the probable answer over the total experiment. All right, yes, Rulani. I want everybody, while I'm answering Rulani's question, to have a look at this example over here.
Hi, ma'am, I'm asking for T. How is it the total time? Because within your example, you made 36 the denominator, but you only rolled it 3 times.
Okay, because every single time you do the example, every time you flip the coin, that's 1/6, and then 1/6 again, and 1/6 again. You understand what I mean? So it becomes
Yes, ma'am.
Am I making?
Yes, ma'am.
All right.
Okay.
Good question. All right, beautiful. Let's look at this next question that we have over here. Okay, it says, an ordinary coin is thrown 50 times. Barry says, I'm going to get heads 25 times and tails 25 times. Explain why he could be wrong. What is he actually doing over here? Is he giving us the relative frequency or is he giving us the theoretical probability? Right? P for probability or F for frequency? Correct. He's looking for the theoretical. He's assuming that he's going to get that because of the probability. So we know for a fact, if he flips a coin 50 times, the probability that he will land on heads is going to be 25/50. And the probability that he will land on tails is going to be 25/50. Both of these theoretical probabilities is going to be the same. Correct. Yes, Elise, he's guessing. He's guessing at it. Right. Now it says, why is he wrong? Anybody gonna venture an answer for me? Why do we know that he could be wrong with this? Yes, Entle, what do you think?
Well, ma'am, I'm taking a wild guess. I think he might be wrong because he divided by 2 just because there's like 2 sides of the coin.
Correct.
And he's
we know that our frequency always going to be 100% accurate?
Yes.
Is it? Let's say we calculate, let's say we actually flip the coin 50 times. Are we going to get that heads came up 25 out of the 50 times?
No.
Are we always going to? No, we're not. So the reason he's wrong is because the frequency does not always match the probability. Okay.
Yes.
Am I making sense? Beautiful. All right. Thanks so much, Entle, for that. All right. And now I want us to actually calculate for the relative frequency. The question here says, a coin is thrown 30 times. Now, this is our T value because this is the total time we ran the experiment. And then it says the coin landed on tails 20 times. What is the relative frequency of the coin landing on tails? So we're going to say F, the frequency is equal to the probable times that it landed on tails, 20, divided by the total times that we did the experiment, 30 times. Then we need to simplify, guys. Don't just leave it at 20/30. The relative probability is then 2/3. That's it. Well done, Sinagukhe. That's it. Correct. 2/3. All right. Let's do this last one over here. A dice is rolled 50 times. Right. It lands on 6 37 times. Write down the relative frequency of the dice landing on A6. Correct, Jessica, that's it, Taven, good. F is equal to, the frequency is equal to the probable times that it landed on 6 divided by the number of times, or the total times that the experiment was done, 37/50. Now, Robin says, the dice is biased towards landing on 6. Do you think the dice is biased? Yes or no? Okay, for those of you who say no, you need to tell me why. For those of you who say yes, you need to tell me why. Biased means that it favors one number over the other numbers. Does the dice actually favor one number over all the other numbers? Correct. Okay, because the die can't choose. Okay, that's a good answer. Zipozonke is like, the die can't choose for itself. Okay, Mhlengi also says the dice doesn't have an answer of its own. Vasha, we could say that it should be 50-50. But if we really look at it, the probability of landing on a 6 on a die should only be 1/6. Okay, it should only be 1/6, right? And if we throw this 50 times, then it shouldn't be any more than 50/300, something like that, right? Okay, but we can say no. In this case, I would say the die is biased because, wait, 50 times 6, yes, 300. Okay. Ooh, my maths is not matching. I'm like, 50 times 6 is 30. No, it is, it's 300. All right, we can say no. The probability should be 1/6. So the fact that you actually threw the dice and it landed on 6 more times than it would if 1/6 or if 50 was a fraction. So 1/6 of 50 is going to equal to how much, guys? Somebody type into the calculator 1/6 times 50. 1/6 times 50 is 25/3. Okay, 25/3 or 8,3. So what we mean by this is, if the die was not biased, then we should have only landed on 6 about 8 times. Only 8 times. We should have only landed on that 8 times. But if we look at the dice actually landed on 6 37 times. Are we seeing the difference between 37 and 8? It's a large difference, right? It's a large difference. So is my dice actually biased? Yes, it is. Because on a dice where I should have only landed on 6 8 times, I landed on 6 37 times. That sounds biased to me. I don't know about anybody else. Naledi says, I was right. Yes, Naledi, you were right. Ooh, Slay Queen with all the dramatics. There we are. Hi, Slay Queen. Okay. It is, Blessing. It's very biased because if it only had to land on 6 8 times, but it landed 37 times, I'm thinking somebody did something to that dice. Somebody did something. It seems funky to me. Or whoever was rolling wasn't rolling the right way. Correct. That is it, Isayan. Yes. But Isayan, the reason I only said 8 is because you can't throw a dice 8,3 times. Okay. Lister was like, it's a casino die. It's a casino dice. Okay, so we're only saying, that's why I said approximately 8 times, because we can't throw a dice 8,3 times. Okay. You can try to get 8,3. Okay, no, that's not going to work. All right, give me a thumbs up if everybody understands how to calculate for relative frequency versus probability. Are we all okay with how to calculate for these two things? Beautiful. I'm going to take I know everybody's going to be like, oh, yes, ma'am, let's do this. But we're going to be learning about Venn diagrams today. So Chifaro, if you're still stuck, I need you to put your hand up for me, please, my sweetie, so that we can have a conversation. Slay Queen, how you doing?
Hey there, my close girly girl.
How you doing?
Sorry, ma'am, I'm good, and you?
I'm good, thank you. What's up?
I was just going to ask if we're doing probability.
Correct. And we are on
okay.
lesson 2, we're studying Venn diagrams today.
Perfect. Thank ya.
All right. Always lovely to have Slay Queen in the house, everyone. Say hi to the Slay Queen if you haven't already. Mfundo, what's up?
Ma'am, I just wanted to ask, ma'am, if we had to get a question like the bias dies, is that how you'd calculate the thing?
Yes. So because this happened, we did the experiment 50 times, right?
Mm-hmm.
What is the probability of you getting 1/6 50 times? Okay.
Yeah, okay.
So you have to take 1/6 times 50 to get that 8,3. Okay. And then you compare that to the actual relative frequency. So this over here is our probability, and this over here is our frequency. Then you compare the two.
Yes, ma'am.
Okay.
Ma'am.
All right, my boy. Good question. Very good question. Buntle, what's up?
Hi, ma'am. What does bias mean? Bias or bias?
Bias means, okay, so let's say, for instance, Buntle, it's you and your little brother, right? And every time you guys go to the shop, your mom only buys your little brother an ice cream. Your mom is biased towards your little brother, okay? Because it favors your little brother more than you, okay?
Oh, okay.
Makes sense?
Makes sense.
Good.
Thank you.
All right. Good question. I think many people were a bit confused as to what bias meant. Okay, let's Venn diagram. Yes, ma'am. Yes.
Princess asked if you could scroll up. She wants to take a screenshot.
I actually had. So when I was answering Buntle's question, I hope that Princess took a screenshot. But I'm going to give you 5 seconds. 4, 3. There we go. She's done. Okay.
Thank you.
All right. Let's talk about Venn diagrams. Now, let's say we have a sample space, guys. If we have a sample space, I'm just going to pick random numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, let's pick these 2 numbers. Right. Now, this is called a sample set. Right. It's a sample set. Right. What we're going to do from this sample set is we are going to make subsets. I'm going to take off my sample set and I'm going to make smaller sets called subsets. Okay, subsets. My first subset, I'm going to call it A. I'm going to ask you guys to find me all the multiples of 2 in my sample set. Look at my sample set. What are all my multiples of 2? Good. 2 and 4 and 6 and 8 and 10. Correct. Okay, that is my first subset, right? My next subset, subset B, I'm going to say, I want all the multiples of 3. What will all the multiples of 3 be? Good. 3, 6, and 9. Right. Okay. So I want you guys to notice something here as we go along. Okay. In both of these sets, which number shows up in both of my subsets? Ma'am, Taven says she can't hear anything, teacher Nels, if you can help, thanks. All right. So we can see that 6 shows up in both of these subsets, right? So when we draw our Venn diagram, we have to consider the fact that we can't write 6 twice. Even though it shows up in both subsets, it only shows up once in my sample set. So how do we draw a Venn diagram? First thing we're going to do is we're going to draw a rectangle, right? And we're going to call the whole rectangle our sample set S. That is S, right? Now, all the numbers in our sample set needs to go into our subset. But because these two subsets, A and B, represent different things, I need to draw two circles, one for subset A and another circle for subset. Why am I drawing squares now? Oh, I meant circle. Okay. Hey, guys, look, guys, I'm clicking on, oh, there we go. Correct, Blessing, good. Subset B, right, subset B. Now, remember, because both of these two numbers show up in both, these circles somewhere need to overlap because they share a partner. So I'm going to take subset B and I'm going to overlap it just a little bit. Okay, let me make that a little bit smaller. There we go. Correct. They will link together. Correct. Okay, I'm going to write B on the other side. Good. Now, let's look at putting all the numbers that we know they have in common together. We know that they have 6 in common, so 6 must go into both our circles. That's why we have them overlap, right? But in subset A, all the other, correct, Isayan, yes, 6 is like the gray area between both of those numbers. Now, in both of the subsets, we still need to add all the other numbers. So there is, in the subset, there is 2, 4, 8, and 10. We've included 6 because it's in the middle. Okay, and then in subset B, we have 3, 6 is already there, and 9. All right. Okay, but we are still missing some things. Who knows what are we missing? What are we missing? Good, not 10, not 10. Does anybody remember what we're missing? Good, 4 is missing. No, 4 is not missing. 5 is missing, 1 is missing, and 7 is missing, right? So those need to go into our full subset, right? 1, 5, and 7, because no man must be left behind. Okay, Taven's having some serious technical issues there. Okay, good. We put them outside the circle, but they must be inside the sample set. They must be inside the sample space. Okay, yes, Siamtanda.
Ma'am, I wanted to ask, don't we put like the total numbers combined where the S is above the rectangle?
Yes, correct. You can, yes, absolutely. You do that. You can go S is equal to 10.
Oh,
right.
okay. Thank
You do
you.
that. The reason I didn't do this in this exact example is because you'll see in other examples where we are actually counting things and we don't have actual numbers. Okay, so for instance, when they say 100 people went to the gym. Now, in that example, we have to then say S is equal to 100. But in this particular example, because we are using actual numbers as values, we don't have to write what it is over there. Because if I write S is equal to 10, what you're actually saying is that there are 10 numbers and we must represent those 10 numbers as numbers. In this case, we're not doing that. We are representing each number as itself. And I'm going to show you what I mean.
Okay, thank you, ma'am.
Always draw a triangle. Or a triangle. Did you mean rectangle? Okay, yes, we must always draw the rectangle. All right, let's look at this first example over here. Now, they've given us our sample space or sample set F over here. Yes, we must always draw the rectangle. Right, they've even named it for us. I think this is lambda. I'm not sure which Greek letter it is. Right, now it says our subset A needs to be all the multiples of 3. Let's go ahead and name all the multiples of 3. A is going to equal 2. Ooh, thank you, Jessica, you're so fast. Shoo. Okay, 3, 6, 9, 12, and 15. I say 15, but I write 16, 15. All right. And then over here, we want the multiples of 5. B is going to be the multiples of 5. 5, 10, and 15. Right. Now, what is our overlap? Which number shows up in both subsets? Correct, in Tlanganipo, that's it, Zibusiso. Correct, 15 shows up in both. So that means that 15 must go in the middle. 15 must go here. All right, now we get to fill in all the other numbers. In subset A, I have 3, 6, 9, and 12. And in subset B, I have 5 and 10. And 15 is in both of them. But don't forget all the other numbers, guys. Correct. All the other numbers go in the big rectangle. Correct. I see Jared saying that to me, but he's DMing me right now, but you've got the correct idea, right? Okay, 1, 2, 4, no, not 6. 1, 2, 4, 7, 8, 11, 13, 14, and 16. All these other numbers will go on the outside, correct? So we need to add all of those. 1, 2, you can put them randomly wherever you want. 7, 8, 11, 13, 14, and 15. All right. Now I'm saying, I mean 16. Okay, I mean 16. All right, give me a thumbs up if everything we've just done makes perfect sense. Okay, Vasha, why do we put them outside the circle? Because they are not part of our subset. They're not inside, they're not part of the circle. Okay, so they go in the big rectangle, which is our big set, our sample set. Okay, they are only part of the big set, so they go into the rectangle. We're going to get to that, Sinogushe. All right, we're going to get to that. Okay, let's do something. No, you don't have to, Ivan. It's not necessary. Okay, let's do something a little bit more challenging. Okay, Princess knows me too well. She's like, thumbs up for now. Okay, Chifaro, remember, we're always going to have our sample set, and then we're going to have subsets. So if it's not in the subset, if it's not here, then it goes in there, in the rectangle. Okay, so if it's not included in our subset or in our subsets, then it automatically goes into the sample set. Remember, Keegan, when we were doing statistics, we said that there's a difference between a sample and a population. A sample means that we've taken a small number. Okay. Yes, Swela, absolutely. Let's do it. Are you with me? Hi, Swela.
Hi, ma'am.
How are you doing, my sweetie?
I'm good, and you?
I'm good, thank you. All right. Do you want to do this example with me?
Yeah. I was young.
Okay.
Now I'm ready.
Okay, that's fine. Okay. Can I just answer Blessing's question very quickly? Blessing says, how do we know which numbers should we use for multiples? You only use the numbers that they give you in your sample set, Blessing. Only these numbers. Okay. All right. I hope that answers your question. Okay, Swella, let's do this question. Now they're saying to us that there are 80 students in year 11. So S, now this time we can write S is equal to 80. Okay. We need our sample space to be there. Now, the first one says 9 students study French and German. 35 students only study French, and 2 students do not study French or German. Ooh, lulu, drama, drama, drama. What are we going to do about what they've written here?
So came in first, 9 is gonna be where the 2 circles interact.
Correct, because French and German means that they're in both subsets. Correct?
Yes.
Good. So 9 goes in the middle. Right. Then what happens when it says 35 students only study French? What does that tell you?
You're gonna take 35 and subtract by 9.
Not in this case. Okay, not in this case. Because if I only study French, then I can't be part of this set. Because if I'm in between here, what does that mean? It means I study
Both.
both. So I can't. So for French only, I have to put 35 here.
Oh.
Am I making sense?
Yeah.
Mm-hmm. Yes? Is it
Like,
making
it's
sense
kind
though?
It is like it's like 50-50 because like in class like we used to like when like they interact like we used to like minus it because
Correct, but
apparently
okay, we're only gonna minus it, Swella, if they say 35 students and there's no only. They say 35 students study French. Then we have to minus. Okay. But in this case, because at the moment, we're looking for kids who only study French, which means they cannot overlap with the German and the French. Okay.
Okay.
Am I making sense? All right, let's talk about this last part here where they say 2 students do not study French or German. Where do those 2 students go?
Around the rectangle, like.
Correct, in the rectangle part too, outside. Right, now what's missing, Swella? What's still missing?
The kids who do what you call German.
German only, correct?
German only.
Correct, German only. So how do we figure out how many kids do German only?
Okay. Can I okay, what about x plus 9? Okay, for German, let's make it like the value of x, ne? Be like
Correct.
x plus 9 plus
So we're gonna
35
plus 9 plus
35 plus 2 equals 280.
Correct, because there are 80 kids in the class, absolutely. And then all we have to do is minus, right? Find what x is. Minus for me, x is equal to what?
Okay, 80 minus. Oh my God. It's like 38. I'm not sure. Like.
Correct, Jared, yes. Okay, so you're gonna minus all the other numbers. Okay, so you're gonna go 80 minus 2 minus 35 minus 9, and that will give us 34. Okay, x is equal to 34. So the kids who study German only is 34 students. Okay, are you with me here?
Yeah.
Okay, good. All right. Are you happy with how we answered for this? Is that okay? Are you okay with what's happened here?
I'm okay. Now I understand it because like the whole week when we're doing what do you call it, the Venn diagram probability, I was absent. So now it's clicking. I'm ready to run my final.
All right, so what we want to do here is we want to make sure that we are understanding the question completely. Okay. Okay, so all of those onlys, when they include only and they don't include only, it's very important that we're listening to those little things. Okay. All right, good. I love how you did this whole question with me. Love you for that. Thank you so much, my sweetie. I feel like I didn't even do much. You did the whole thing. Thanks, Swella. Love to see it. Good. No worries, Princess. I'm not moving. Blessing, what's up?
Hello, ma'am.
Hi, my boy. What's up?
Ma'am, I didn't get clarification on the question I asked. So, ma'am, my question was that on the previous question, they said find the multiples of 3 and 5, if I'm not mistaken.
Correct.
So, is that given in the question or you should find it out yourself?
No. Okay. Remember, all of those multiples of 3 and multiples of 5 must come from our set, must come from here. Okay, so you're looking in this set, what are the multiples of 3 in those numbers that they've given?
So, ma'am,
Okay,
how
so you can only choose from these numbers.
okay, how exactly do we know that we should use 3 or 5?
They will tell you. The question tells us that we must look for the multiple. And the question tells us to look for 5.
Okay, thank you, ma'am. Yeah,
Right.
that's all.
Good question. Good question. No worries. Slay Queen, what's up?
Yo, ma'am. Yo. So like I looked at this thing, right? And I was like, light work, no reaction. And then up until you put the 9 in the middle, I was like, it's got a little kick to it.
Okay,
So
yes.
like now
So
I just
think
got
about
like
this.
super lost.
If you study German and you study French, we can't count twice. Do you agree with me?
Yeah.
We cannot count twice. So if you study French and German, we need to make a space for you where the 2 of them overlap.
Okay.
Okay, so that's why the 9 for the kids who study both French and German goes in between where the 2 circles actually touch each other.
Meet.
Am I making sense there? Right. But if you only study German, I can't, or if you only study French, I can't include you with this 9 because the 9 in the middle are for the 9 in the middle is for the kids who study both. Okay,
The
so if
bilingual
you study French, you need to go here.
Sure.
Okay, and if you don't study any of them, 2 students do not study any of those, they go outside the 2 circles. We can't include them in the circles that talk about French and German. Am I making sense?
Okay. So they're ghetto.
Okay, we will say that, yes, they're ghetto for not studying a single language, right?
Okay.
Now, we then have to figure out how many of the kids only study German. Right?
Yeah.
But if you know that there are 80 kids in the class,
Yeah.
then only counted the kids who take French and the kids who don't take any subject at all and the kids who do French and German. What about the kids who do only German? That's going to be
the equation.
Correct. That's hence the equation. All of them together must add up to 80.
Okay.
Okay. Does that make sense?
Yes, ma'am. I'm driving. I drive a little bit.
Beautiful.
Just a little bit.
All right. Excellent. I think you've offended a lot of people who don't do French or German by calling them ghetto. That's a story for another day.
Merci beaucoup for real, mom. Not my problem.
Okay, thanks, my sweetie. Leah, I'm going to take Jared's question very quickly while we continue. Okay. Hi, Jared. What's up?
Hey, ma'am. Would you say these are like one of the simplest questions, or are these like hard ones for you?
This is most definitely the simplest question. So in the next lesson, we're going to step it up a notch. Okay.
Okay. Thank you, ma'am.
You're very welcome. We're just getting started. Okay. We're just getting started. Leah, what's up? Teacher Nels, I'm going to ask you to pop the link to the quiz in the chat because this is where we're going to stop for today. I don't want to complicate anybody's life anymore. Hi, my sweetie. Always looking lovely in your,
Thank you. Hi, ma'am.
Hello.
Ma'am, I just want to ask about the Venn diagram. At first, I was confused about why you put the 9 in the middle. So I was just asking, like, if I say the G letter circle is for German, then F letter circle is for the French. So
correct.
I was confused about why 9 was put in the middle. So it shows that D and F, because they are not students that shares French and German. So it means that 9 stays in the middle because German, French, so
together, yes. So whenever we see the word and, Leah, whenever we see and, we know that our circles must touch. Okay, because the kids who do both of those things and both, they must go in between the 2. Okay.
Okay, thank you.
You're welcome, my sweet.